Hi, welcome to this video series about .NET Interoperability and Microsoft Dynamics NAV. This is part 2 of a total of 3 videos. In this video we will look at the power of .NET Framework. We will walk through a series of very useful and powerful classes objects that we can use. First of all, we will look at arrays and collections in .NET Framework and how to use them in Microsoft Dynamics NAV. And then we will see how we can use .NET to handle files directly from the Microsoft Dynamics NAV. And finally, we will look at streaming. How does the in-stream and out-stream in Dynamics NAV work together with the stream objects in Microsoft .NET Framework. So we first start with arrays and collections. The .NET array contains a fixed number of values. You can roughly compare it with the array in CAL code. In an array, all values are of the same type. The system.array class in the .NET Framework provides methods to manage arrays, to create them and to add values to it and to get values from it. It serves as a base class for all arrays in the different languages of .NET. When looking at the system.array class, there is a notable thing. It has no constructor. Instead, we need to use the createInstance method to create an array. This method takes arguments for the type of data that we want to store in the array and the capacity of the array. It then returns an array with the correct type and dimensions. With the setValue method, we can store a value at a given position in the array. The getValue method returns the value from a position. And with the property length we can check the total number of elements in the array. In Dynamics NAV we can easily loop through the array by using the forEach command. Here you'll see a .NET system.array class defined in CAL. This class resides in the MS core lib assembly. This code example shows how to create a new array to store strings. Look at the get.NET type command that is used to return a .NET string type. The array has a total number of 5 elements. Since everything in .NET is 0 based, the index is numbered from 0 to 4. In this example, we use the for command combined with the length property to loop through the array. The getValue method returns an object from the given index. If nothing is stored, a null value is returned. Here is the same example, but now we use the forEach command to loop through the array. With the forEach command we don't need the getValue method from the array. In each iteration the .NET string variable is automatically set with the next value in the array. Since we use a .NET type here, we still can test if the value is null. The collections namespace contains classes that are more advanced. They are an alternative to the array class. An important difference is that a collections class can dynamically resize when new items are added. The system.collections.generic namespace has classes that define generic collections of any type. Let's take a look at 2 classes from this namespace. The list class can be used to store a list of strong typed objects. The elements can be accessed by using an index, or we can iterate through the elements using the forEach command. And what's more, the list class provides methods to search, sort or manipulate the stored values. The dictionary is a class that can be used to store values together with a key. It provides methods to fast look up the content using that key. Here we see the declaration of a CAL variable of the type generic list. This class resides in the MS core lib assembly. This code example shows how the list can be instantiated using its constructor. Values can be added by using the add method. We can sort and reverse the order of elements. And looping through the collection is really simple using the for each command. This is a declaration of a variable of the dictionary type. Again, this class resides in the MS-corelib assembly. In this code example, we store the values in the dictionary with a key that we define ourselves. With the item method, we can directly pick one of the stored values based on the key. Let's now look at handling files from dynamics NAV using .NET classes. The system.io namespace contains classes for reading and writing to and from files or data streams, and the classes provide all basic methods and properties that we might need to manage files. The file and file info classes have methods for all types of operations that we want to do with files. The file class is a static class that can be used for recurring tasks on different files. The file info class is an instance class and is the better choice when you need to do multiple operations on one file. The directory and directory info class have methods to work with directories. They also provide methods to get a list of all files in a certain directory. The directory is a static class and directory info is an instance class. With the path class we have operations to work with strings that contain file or directory paths. So there is a method to combine two strings to create a complete path. And we don't need to worry about a slash in between because the path class handles that for you. Here you see a number of CAL variables defined as system.io classes. As you can see, all classes are again located in the MS-corelib library. This code example uses all types to copy a complete directory including subdirectories. The dir.info class gives us the source directory. With the directory class we create a target directory if it is not existing. Using the for each command we loop through all files of the source directory. The getFiles method returns a list of file info objects that points to a single file in the list. The file info class has a method copy_to to copy the file to a new destination. The destination is a complete path that we combine using the destination directory and the original folder name with the path class. With the getDirectories method we get a list of all subdirectories. This is a list of directory info objects that we loop through and do a recursive call to the same function. Let's now look at streaming. The system.io.stream class represents a sequence of bytes. It is an abstract class that has a number of derived classes. The most useful classes are the memory stream, which holds a sequence of bytes in memory, and the file stream, which gives access to the contents of a file. The CAL types instream and outstream are compatible with the system.io.stream and its descendants. This means that we can assign a .NET stream to an instream, for example, or the other way around. Here are some examples of how we can pass streams between CAL and .NET. XML ports can export to a .NET stream or import from it. We can also use the .NET stream in the CAL command copyStream. And if a .NET method has a parameter of type stream, we can pass an instream or outstream to it. Here are again a number of CAL variables declared as .NET types. Please note that the stream classes are again located in the MS-corelib assembly. Only the XML document that we are going to use in the next code example is from a different assembly, the system.xml assembly. In this code example, we use an XML port to export data to a memory stream. Next we load that memory stream into the XML document. This is not needed before saving it to a file, it's just for demonstration purposes here. The .NET file.open command returns a file stream object that we then use to import it again with the XML port. Some tips and limitations with streams. A .NET stream is both in-stream and out-stream at the same time. It has methods for reading and writing. And we can use a copy between two out streams by using a .NET stream. The .NET stream can be manipulated with code, but the in-stream and out-stream cannot. And it is not possible to create a .NET stream with the create in-stream or create out-stream commands in CAL. Finally, let's look at a specific possibility with .NET streams. A byte array is an array that holds a list of bytes. This is extensively used in .NET. Many methods return an array of bytes. We can convert such a byte array to a memory stream. This opens the possibility to write a byte array into a blob field. Let's look at an example for that. Here we have a CAL variable declared as a .NET array. This is the class that we started this video with. We have also a web client class and a memory stream. This code example uses the web client to download data from a URL. The download data method returns an array of bytes. This byte array is then used as a parameter to the memory stream constructor. This results in a memory stream that holds the complete downloaded sequence of bytes. Then we create an out stream on the picture blob field and use copystream to copy the memory stream to the out stream. With this code we have downloaded a file from the internet and stored it in the database. So let's summarize this video. We have seen arrays and collections. They help us to control data collections. In the system.io namespace we have many classes to handle files and folders in a very convenient way. And the streaming in .NET is extremely powerful to use and is a very good combination with Dynamics NAV in and out stream. In this video we have covered arrays and collections, handling files and streaming. This was part 2 of a series about .NET interoperability with Microsoft Dynamics NAV. More information can be found on this URL. Thanks for watching. This video was brought to you by Microsoft and Cloud Ready Software.